So let's talk about simplicity. So the human brain is very good at recognizing patterns. It's kind of our major skill. It's something that sets us apart from computers. We're very good at this in particular, as opposed to doing like mathematics and stuff like that. But it's an amazing skill we work our whole lives to develop because it sort of allows us to look at complicated, unsolvable problems and break them down into solvable parts. So our brain sees how bits and pieces of our visual field match with other bits and pieces, and how that all of that sort of matches similar shapes that we've encountered in our past. And it's a very useful process for us to quickly interact with complicated systems. But it has many drawbacks, just the human process of simplifying things down. We make a lot of assumptions, and we take shortcuts, categorizing things that don't necessarily fit together in order to sort of make a more coherent whole, a whole that sort of makes sense to us, that leads us to sort of believe that the world is actually a whole lot simpler than it is. The world is a very complicated place, a very chaotic place, but we sort of make sense of it by imagining order on it or projecting order on it. And once that image of order is solidified in our heads, we're very resistant, as I was talking about before, to taking it apart again, to correcting. Human beings appreciate simplicity, and in fact, we sort of tend to expect that the world around us, especially so in a designed environment such a game as a video game, to be ordered and simple. So much so that we all often ignore or set aside important information, anything that's perceived as unfamiliar or chaotic. And so it's really it's part of the designer's mandate to be careful how much information they're providing to the player at any moment and provide them just enough information to get by. Essentially learning about the environment is a very rewarding process, and that's the thing. It has to be a process. It has to be something that you sort of give to them a little bit at a time. So Rudolf Arnheim, in his landmark 1954 book, Art and Visual Perception, Psychology of the Creative Eye, talked about this concept of simplicity, and gave this as an example. If you were to imagine, okay, so this is sort of connect the dots. How do we connect the dots here? How do we, essentially, how do we draw a figure, a two-dimensional figure here, that would include all four of these points on it? Most likely, you as well as I, and any human being, would probably fill in fill in a figure like this, because this is essentially the simplest way of creating a figure that connects all four of these. There's a couple of other, there's an infinite number of other ways that these could be connected. So if you imagine basically these shapes right here, and we default to figure A because, of course, why would we insert extra complexity here that doesn't necessarily need to be there? While we could assume, I guess, that yes, there's a figure that connects all of that ways in a more complicated way, simplicity of the human brain sort of breaks things down to what is the simplest that we can possibly get based on the information that we have. And when we're talking about shape design and layout design, spatial design, this often comes down to an idea of shape primitives. So these are sort of the three forms, or breakdown of forms that sort of have the least tension to them, the most the easiest to sort of understand in our head. And human beings tend to use these sort of forms in order to describe a lot of their environment. So in cases where you have sort of an oblong shape or some sort of shape that's sort of out of whack, it has a lot of nooks and crannies, something that sort of vaguely implies a triangular shape. People look at these sort of ambiguous shapes and try to even them out inserting order and balance where it's needed in order to fit the desired shape. So the desired shape is that they're able to mentally map a space that is as easy as possible. So they're going to go through a process called that Arnhem calls leveling, which basically levels out the mind's image of the space and will even out sort of the anomalies, enhance symmetry and affinity with different objects. It drops details that don't fit into this perfect image. And by doing this, they've created a simpler space that's easier to understand, but it may be very inaccurate, causing confusion later on as they continue to experience the space. So, and in addition to sort of like these just straight up primitives, as I was showing, I guess, particularly the previous slide, we're absolutely fine, I think, with stretching out into sort of primitive variations. So in cases like this, ovals, all rectangles are sort of variations of a square. There's lots of different ways to make a triangle. There's lots of different ways to make different sort of figures. And of course, there are other figures, things like hexagons, pentagons, things like that, that the player is able to get their head around. But it's really sort of these original primitives that are sort of the basics of that. So I want to return to an idea that I talked about back in lecture 4 when we were talking about image composition, and that's this idea of a structural skeleton.